Assalamualaikum and good day class. Can you hear my voice clearly?
Yeah. Yes.
Yes, yes.
All right. Basically, I'm going to continue what I just did from the previous class. So what we had discussed on the previous class, I need you to draw the free body diagram nicely and accordingly to the question. And please convert from the picture given to the correct FBD. If you make a wrong FBD, so you will get the wrong answer for your question. So today we will continue for T3 and T4 for tutorial 3 and T4. So basically, I cannot go around and see you like I did in the class. So we're going to do solution for T3 first, part 1. So as stated here, we have two cases, inclined at 45 and this one is not inclined. So from the question, Muhammad driving. What of your friend driving? Riding motorcycle. Hopefully everything is safe with him. I can see him clearly. Okay. So we're going to do number 3. And before anything else, as you can see for this question, we're going to pull the weight by using a pulley system. All right. If you went to the museum or to physics thing classes, I just want to do some recap on this matter about the pulley. You can search this online. Okay. If we have a pulley system like this, we have to machine thing here. So we're going to try to push that 10 Newton. The effort we need here is 10 Newton as well to lift up that 10 Newton weight. How about this system? The pulley system you have arranged like this. And we have two loading supporting rod. For this case, if we want to lift that, the effort we need to lift here is W divided by 2 or 10 Newton divided by 2. So the effort we need to lift this 10 Newton is 5 Newton effort. Right, that's the pulley system. So hopefully you can try to do by Googling in the internet. There's a lot of information about that. And next is the system in our question is that way. We have this arrangement. We have 3 mechanism, 1, 2, 3. And that's mean we have supporting load rope is 1, 2, 3. For this case, if we want to lift 300 Newton, the effort we need is W divided by 3. So the effort we need is 300 Newton divided by 3. So we just need effort or power to lift this 300. We need 100 Newton. Okay, clear with that? So we need to use this concept to solve our question T3. That means effort to lift this is divided by 3. All right, we back to the question. For T3, first of all, you need to draw the free body diagram. How to mute you? I don't know. Okay. All right. So as I said in the class, you just draw orang lidi. It's enough. Very simple man like this, like a cartoon. Or you can draw a box like that. Then you have to put the forces accordingly. So this is the free body diagram for this case. Due to the weight is 90 times 9.1 Newton. Due to the friction, we have F, and we have normal force upward, normal force N. So here we have F, then we have, F, friction force due to the that man on the feet, on his shoes or whatever. You have to remember that on surface on the earth. Yes, we have normal force. Then from the pulley, as I said, the pulley system, you have to divide by 3. So the weight of force is W divided by 3 at angle of 45 degree. So please draw this FBD correctly. Okay. So I know you had the right answer from your calculation. And also you can draw this way, a box about the same as well. So next, what we have to do, take the summation of Fy equal to 0, positive upward. Then our W3, we have to resolve into vertical and horizontal. I mentioned in this class, previous class already. So use for the horizontal, become W divided by 3 sine 45 plus N, this N minus the weight, 90.981. So we cannot solve the equation yet. So we name that as equation 1. All right. Then what we have to do, we have to take summation of Fx, sorry. Fx equal to 0, positive to the right. For the Fx is this one. So to the left, so that's negative. W divided by 3 cos 45. Then plus by the friction force, which is F mu N. As you can see here, the mu S is 0.6 times by normal force N. So expand that, we have second equation. Then we have to take, so from equation 1, you arrange that, we have third equation. Then we substitute 3 into 2, we get our N. Then substitute into 3, that value, we get our W. So that's the W we need to lift that load. Okay, so we done for this tutorial 3. So later on, I'm going to give this video to you so you can study. So any question? I think this one a bit clear. The most important thing I want to share about the free body diagram, you have to draw correctly, and also about the pulley. You can learn about the pulley. This is just information about the pulley. We need less effort to lift the weight. So next, you have to draw for the second question. So this one. For the second case, B, This one. Draw this FBD. Oh, sorry. So for this case, the W divided by 3 change here. Okay. So when you draw FBD, make sure you draw correctly. Okay. All right. I just draw the FBD for you, so you can try yourself to solve this B part B. Okay. Next, we go to the last one. Number 4. The man tried to push the crate with the weight of 68. The mu s given to us is 0.5. So we need to find what is P to ensure the crater is moved. Okay, which is this crate will move to the left or slide. So what we have to do, we have to draw the free body diagram first. For the last question, so from that case, all right, you draw your box and the dimension first. And for sure, the center of gravity at the middle. So please read the question accordingly, or be careful with this question and see is it the G location is given or not. All right. So draw the dimension first, then you put all the information given. So what given to us is P, weight of the crate. You have to convert into Newton, and also P value, P, the force the man tried to apply to the crate. And then for this part, if you not understand yet, please study example 3. Okay, in this question, want to know the minimum P required to make sure this box or this crate can slide or move. So we take assumption at point A, anywhere at distance X. And for sure, for this case, due to this P, we have friction force, and also we have normal force at point A. And given to us is mu s 0.5. Right, clear with that? Free body diagram. So we done free body diagram. Then what we have to do, for the first step, we take summation fx equal to 0, positive to the right. So that's mean F minus P for the first equation. So we done for the first equation. We go for Fy. Fy equal to 0, positive upward. So we have our N, then we have our weight. So N minus by this weight equal to 0. So we get our N is 667.08 Newton. So we done on Fy. Then what we have to do, we have to take moment at point A, positive anti-clockwise. So we have P to point A is anti-clockwise, that means is positive. Positive P, the perpendicular distance for that is 0.9. Then we have, due to the weight, we have our N. Our N already calculated. Our N is 667. Oh, sorry, not. Okay, I made mistake. I think this one is where's my calculator? 68 times 9.81. Okay, this is stick. Just you can see here because this value about the same. This is from here, from this value, okay, minus 67.08 to point A is anti-clockwise, clockwise. So that means it's negative times by x. So have equation. So we solve this. We have our P is 714.2 x. Then due to the friction, for sure this is a friction topic. Due to the friction, we assume, assume that crate will slide before tipping. If you not understand about tipping or whatsoever or slide, please refer example 3. Because next week we're going to move to chapter already. So please refer example 3. So due to the friction, we use friction formula F mu S, mu times N. We know our mu and we know our N here. Our N, if you times that, we have 335.54 Newton. So we substitute this into 1. We have our P is 33.54 Newton. So from equation 2, we solve that, we get our X is 0.45. So we check again. Here is our X is 0.45. But as we can see here, our dimension here is 0.33 only. So what does it mean? That means with the force from that guys, this box will tip over. But in the question 1, our box is light, not tip over. So since its X is bigger than 0.3, the crate tips over before it slide. That means our assumption was wrong because we want the condition that box only slide. What we have to do, substitute X equal 0.3 into equation 2. Then we get our P value is 222.36. That means this is the force required by that man to make sure the crate is light, not tipping. All right, so this is the solution for question number 4. So to those still stuck on this thing, because from my observation, some of you still curious about this, please do the example. I think example number 3, explain about tip and slide. So, any questions so far? I think it's go very fast. Tak ada eh? So later on, I'm going to share this slide to you because I cannot go around and see your handwriting. But please make sure for next Monday, please write. Ada nak masuk. Please write in line A4 paper, okay? Because I